Cylinders and quadric surfaces. Definition. The curves of intersection of a surface with planes parallel to the coordinate planes are called traces, or cross-sections of the surface. And a cylinder is a surface that consists of all lines called rulings that are parallel to a given line and pass through a given plane curve. So sketch the graph of a surface z equals x squared. So z equals x squared is a parabolic cylinder. The rulings are parallel to the y-axis. So these would be the rulings. The variable y is missing, so this extends along the y-axis. And this is what's referred to as a parabolic cylinder. Identify and sketch the surface. X squared plus y squared is equal to 1. So in the xy plane, this is a circle. Since z is missing, the circle extends along the z-axis, which forms a cylinder. So here's the x-axis, here's the y-axis, and then this would be the z-axis. So this is a circular cylinder. The rulings would be parallel to the z-axis. So this is made up of circles. Y squared plus z squared equals 1. Since x is missing, this would extend along the x-axis. So the rulings are parallel to the x-axis. This is a circular cylinder where the axis is the x-axis. So here's y, here's z, and then that's your x-axis. So this is a circular cylinder where the axis is the x-axis. Definition. A quadric surface is the graph of a second degree equation in 3 variables. X, Y, and Z. The most general equation is ax squared plus by squared plus c z squared plus dxy plus eyz plus fxz plus gx plus hy plus iz plus j is equal to 0, where a, b, c, and j are constants, but by translation and rotation, it can be brought into one of 2 standard forms. Ax squared plus by squared plus c z squared plus j is equal to 0, or ax squared plus by squared plus iz is equal to 0. Example, use traces to sketch the quadric surface with the following equation: x squared plus y squared over 9 plus z squared over 4 is equal to 1. So first, let's take a slice in the xy plane. So in the xy plane, if z is equal to 0, then this equation turns into x squared plus y squared over 9 is equal to 1, which is an ellipse. If z is equal to some constant k, then this equation turns into x squared plus y squared over 9 equals 1 minus k squared over 4, where k is between -2 and +2. If I take a slice in the YZ plane, in the YZ plane, x is equal to a constant, then this equation turns into y squared over 9 plus z squared over 4 equals 1 minus k squared, which is also an ellipse. Last, if I take a slice in the xz plane, then y is a constant, which that equation turns into x squared plus z squared over 4 is 1 minus k squared over 9, which is also an ellipse. So this is always an ellipse, regardless of which way the slices are. So graphically, y direction, x direction, and z direction. This point here is 1, 0, 0. This point here is 0, 3, 0. This point on the z-axis is 0, 0, 2. And this is called an ellipsoid, since all traces are ellipses. For the following example, use traces to sketch the surface. Z equals 4x squared plus y squared. So first, if I take a slice in the YZ plane, I can choose x to be 0. If x is 0, this equation turns into z equals y squared. If x is some constant k, this equation turns into z equals y squared plus 4k squared. So z equals y squared is a parabola. Y squared plus a constant is also a parabola. So this is a parabola in the YZ plane. If I take a slice in the XZ plane, so y is a constant. If y is a constant, then I get z equals 4x squared plus k squared. This is also a parabola in the XZ plane. Last slice in the XY plane, which means z is a constant. If z is a constant, then the equation turns into 4x squared plus y squared is equal to k. Since k is a constant, if I divide everything by k, this will turn into an ellipse. So this is an ellipse in the XY plane. So here's x, here's y, here's z. Here's a parabola. And then here's a parabola. In the XY plane, which is this plane here, this is an ellipse. So it's a mix between ellipses and parabolas. So this is called an elliptic paraboloid. Sketch the surface. Z is equal to y squared minus x squared. So first, if I take a slice in the YZ plane, so x is a constant, implies z is equal to y squared minus k squared. So if I graph this in the YZ plane, here's y, here's z. If k is 0, I get z equals y squared, which is this parabola here. If k is plus or minus 1, I get a parabola shifted down 1. If k is plus or minus 2, I get a parabola shifted down 2. So the family of curves are parabolas. This is k equals 0, this is k is plus or minus 1, and this is k is plus or minus 2. If I take a slice in the xz plane, then y is a constant, which means z is equal to k squared minus x squared. So in the xz plane, if that's x and this is z, if k is 0, z is negative x squared. So this is if k is 0. If k is plus or minus 1, I get the parabola shifted up 1. So this is k is plus or minus 1. If k is plus or minus 2, I get the parabola shifted up 2. So this is k is plus or minus 2. So the traces are parabolas also in the xz plane. Last, if I take a slice in the xy plane, which means z is a constant, then k is equal to y squared minus x squared. So y squared minus x squared. Is a family of hyperbolas. If k is 0, y squared is equal to x squared, which means x equals y and y equals negative x. So this would be x, and this would be y. If k is 1, then I get this hyperbola. So this is if k is 1. If k is negative 1, I get this hyperbola here. So if k is 1, it's an up and down hyperbola, or a vertical hyperbola. If k is negative 1, it's a left-right hyperbola. And if k equals 0, the lines are at y equals plus or minus x. So if I combine all of these traces together, I get this sort of curve. I get a curve called a hyperbolic paraboloid, where it's a mix of parabolas and hyperbolas. So it looks like a saddle, but it's a hyperbolic paraboloid. Example, x squared over 4 plus y squared minus z squared over 4 is equal to 1. So if I take a slice in the xy plane, that means z is a constant, which means x squared over 4 plus y squared is equal to 1 plus k squared over 4, which is an ellipse. A slice in the xz plane, which means y is a constant, would be x squared over 4 minus z squared over 4 equals 1 minus k squared. Since one term is positive, one term is negative, this is a hyperbola. And then last, a slice in the yz plane, which means x is a constant, so this equation becomes y squared minus z squared over 4 equals 1 minus k squared over 4, which is also a hyperbola. So in the xy plane, I have an ellipse or ellipses. In the xz plane and yz plane, these are hyperbolas. So the horizontal slices are ellipses, while the vertical slices are hyperbolas. So this graph so here's x, here's y, here's z. Here's my ellipse, and then these are the hyperbolas. So this point is 0, 1, 0, and this point is 2, 0, 0. This is called a hyperboloid of one sheet. Okay, identify and sketch the surface. Four x squared minus y squared plus 2z squared plus 4 is equal to 0. So if I subtract the 4 over first, 4x squared minus y squared plus 2z squared equals negative 4. If I divide everything by negative 4, I end up with negative x squared plus y squared over 4 minus z squared over 2 is equal to 1. if I combine the terms that are negative, so negative x squared minus z squared over 2, and then plus y squared over 4 is equal to 1. So since y is positive, the axis is going to be along the y-axis. And this is a hyperboloid of 2 sheets. Which the graph will look like this. Example, x squared plus 2z squared minus 6x minus y plus 10 is equal to 0. So I need to complete the square to be able to get this in the form to graph it. If I group the x's, x squared minus 6x, I'll leave some space, plus 2z squared. I'll move the y term to the other side. So equals y, and then I'll move the 10 to the other side to make it a negative 10. To complete the square, I need to take the coefficient of x, as long as the leading coefficient is a 1, divide this by 2 and square it. So negative 6 divided by 2 is negative 3, squared is 9. If I add 9 on the left side, I gotta add 9 on the right side to balance it out. And then I can factor x squared minus 6x plus 9. This will factor into x minus 3 quantity squared plus 2z squared is equal to y minus 1. So y is not squared, so y minus 1 is equal to x minus 3 quantity squared plus 2z squared. Because x is squared and z is squared and there's a plus, this is some sort of ellipse. So it is elliptic. Y is not squared, so it's a paraboloid. So the axis is parallel to the y-axis, but it's shifted by 1 unit. So the vertex is 3, 1, 0. And the graph would look like this. This point here is 3, 1, 0. And then the rulings would be along the y-axis. So this is another elliptic paraboloid.